And I finished that last video just in time because that's about the time that the internet service in the entire city of Richmond, Virginia went down. Hopefully it wasn't anything I did. I guess I'll find out later if it was. But I ran debug IP packet again. We're right back where we were on router 3. I sent a ping over and we see the word unroutable. And this doesn't mean that the packet was corrupted in any way. It just simply means that literally these packets aren't even leaving the router. We're not seeing the word sending this time like we did with the good ping and the debug, because they're not even leaving the local router. Because router 3 is looking in its routing table and saying, hey, I don't even have a beginning to have a route here that matches 2222. There's nothing here that will match that. And on top of that, there is no default gateway set on this router. So the router just goes, you know, hey, I tried. I looked in my table. There's nothing I can do. I'm just dropping the packets. So we need to do a little something about that. And we're going to use, first off, I'm going to do a UALT, turn it debug off. We're going to use a different kind of route this time. We're going to use a host static route, or a static host route, however you want to call it. We're going to write a static route that matches one and only one address, and it's going to be 2222. So let's go ahead and do that. And we start with the IP route command, and we're going to stick just with the destination prefix here. We're leaving those other three options for later. And I'm going to match it exactly to that one IP address. And then I'm going to be asked for the destination prefix mask. And for my prefix mask here, I want all ones because I want to match that IP address exactly. So if I'm doing that and it's all ones, I'm putting 255, 255, 255, 255 here. Now I am not done, but I'm real close. I have two choices here for my last value. And hey Chris, that looks like more than two choices. And I agree with you, it does, but technically you have two choices, and here they are. This will come up on your exam. You got to know it for the real world, but this is going to be on your exam one way or the other. You either have to put the IP address of the next hop router, the interface that's going to receive the packet after we send it, or the local router's exit interface. Very important distinction there. You're either setting the downstream router's IP address that should receive this packet, the next hop IP address, or you are going to enter the local router's exit interface. Very important distinction there. So here, what I'm going to do is send it to the next hop IP address. Now, your question right now is probably, well, which one should I use in different situations? Really, neither one is necessarily better than the other. I have found in more complex networking that it's better to put the next hop IP address, because that way you know exactly where router 3 is sending these packets. And if you're still running into an issue, it makes it easier to troubleshoot that issue, especially in a larger network. Because if I put the interface here, if I put, you know, serial 0/1/0, the command would work because I'm putting the local router's exit interface. But instead of being more determinative about where I'm sending the packets, I'm just saying, hey, chuck them out this interface and let's hope the downstream router knows how to handle them. That's not really like the way I like to do it. If that's the way you want to do it, fine. There's nothing wrong with it. But I just find that using the next hop IP address is a little bit easier to troubleshoot if you end up doing so. Now, what's going to happen then on a live router if I put the local router's IP address here? Because I know I need to put what? What address should I put here? And we'll even go back to the diagram. The next hop IP address is 172.12.123.1. It's not .2, because that's why I was hitting you over the head with that spoke-to-spoke business. We know that this traffic leaving router 3 going over to router 2 has got to go through router 1. So the next hop IP address for this traffic as it leaves router 3, the downstream interface that we want to receive it, is actually 172.12.123.1. Now, if I put 172.12.123.3, which is the local router's exit IP address, it's going to say, hey, Chris, invalid next hop IP address. And I love the paren here. It actually says, it's this router. So the router is kind enough to tell you that. The exam will not. So just one more time, if you see an IP address at the end of this command, it has to be the downstream router's IP address, your next hop IP address. If you specify an interface here, whether physical or logical, it's an interface on the local router. Whew, okay, no more of that for a little while anyway. So let's go ahead with that, and that's the end of the command. That's all I'm required to put. And I've got the next hop IP address there, and I'm good to go. Let's see how that looks in the routing table. And we have a new route right up there at the top, 2222. And it's got a little couple of numbers in brackets there that we haven't seen before. There's a 1 and a 0. We're going to come back to that. Right now, I'm just concerned about getting this connectivity set up. Notice that it has the letter S next to it. And as you would expect, that stands for static. You'll notice most of these do. You know, L is local, so we're ignoring those for right now. C is connected, S is static, R is RIP, B is BGP, D is EIGRP. Huh? Very quickly, the reason that D stands for EIGRP is because the letter E was already in use by another protocol at the time EIGRP came along. So they just went backwards one letter and gave it a D. So let's see. What do you say we send a ping over? Let's see if we can ping 2222 now. See if we can ping that loopback. We got our static route, so we're good to go there. And that is a fascinating ping result. That is one we haven't seen to date. But ugly, I would call that. A U and then a timeout, and then a U and then a timeout, and then another U. The only thing that's good about this is it's a really great indicator of where the issue is. And when you've seen these in a lab and then you go out to production network one day or you're taking an exam and you see that, it's like, okay, I know what's going on here. And here's the thing. Notice that we're not seeing what we saw before with 5 timeouts. Let's see what happens with a debug. And then we'll send the ping again. Another thing with debugs here that I want to mention is that either in a production network or in a lab or in a practice exam or on the real thing, and this has happened to me in all 4 situations, you're going to see a debug output sooner or later that you haven't seen before. And when you're working with something you haven't necessarily seen before, it's easy to lose your head a little bit, and I'm going to use the P word here. I'm going to say panic a little bit, but don't do it, because the thing is, even if it's debug output that you haven't seen before, if you remain calm, you can see what's going on here. And if you start at the top here, you can say, okay, you know, we've got some packets leaving 123.3, and that's local. And there's D for destination for 2222. And they're going out this time. Now, the failed ping in the last video for that same network, those packets weren't going out, right? They just said unreachable 5 times, or excuse me, unroutable 5 times, and that was it. So these packets are going out. And we are also getting a reply, because notice that we have some other rows here that says source 172.12.123.1, and the destination is the IP address here, 123.3. So it looks like that, looking at this debug, the packets are leaving router 3, and they are destined for 2222, and they are leaving. You know, we see the word sending. And also we're getting something back from 123.1. What are we getting back there? Everything else looks pretty much the same, but we just know at this point, even with those hints, that the packets aren't going through. And we will pick up right here at the beginning of the next video, solve this mystery, write a default static route, and we'll see if that takes care of the problem. See you there.